All right, so here's your example problem for this redox reaction of iron nitrate and potassium permanganate in acidic solution to oxidize the iron and reduce the manganese, one of the byproducts being water. So I filled out the table for you for what I know. Remember that the volume has to be translated to liters. So for your analyte, we know we use 28.0 cubic centimeters or milliliters of permanganate ions. So we know that in liters, that's going to be 0.0280 cubic decimeters. And I did the same thing with the volume of the iron here as well. 0.0250 cubic decimeters is my volume for my titrant. The potassium permanganate, or the permanganate ions, are going to be my analyte because I don't know the concentration. And my titrant is going to be my iron ions because I do know the concentration and the volume. So step one, I'm going to go through and come up with the number of moles of iron that I used using my concentration equation, rearranging to find moles, and that's going to be 0.0100 times 0.0250. So the number of moles that I get, I will just put back up on the box here, with three significant figures is 2.50 times 10 to the negative fourth, and that is in moles. So there is another little secret to this, and this is why I've got the balanced chemical equation up here. I see that the ratio of iron plus 2 to permanganate is a 1 to 5 ratio. So for the number of moles that I have of my iron ions, 10 to the negative fourth moles, and these are going to be Fe plus 2s. I have to say for every 1 permanganate, I have 5 Fe plus 2s. It's in a 1 to 5 ratio. So essentially I'm dividing that number of moles by 5, and I get 5.00 times 10 to the negative fifth moles of permanganate. So I'm already on my last step. I'll put my last step in blue. I know the volume, I know the number of moles of permanganate, and so here I come over here and just am going to use my concentration equation one more time, where my number of moles is the 5.00 times 10 to the negative fifth, and my volume is going to be the 0.0280. And my concentration then, when I divide by the volume, is going to be 1.78 times 79, times 10 to the negative third moles per dm3. And that's what my final answer is for my concentration. Now, they will give you a redox titration equation, probably I'd say about 70% of the time on your paper twos. So when you look at this, not only know the process, but definitely check your sig figs as well, because they will take off points for incorrect sig figs. So there you go. That's how you do a titration reaction with a redox reaction. Thank you so much.